Okay, so we are back with finding slope between 2 points. It will be important for us to know that the slope formula is the change in y over change in x, which is y2 minus y1 over x2 minus x1. And so for each of these, we'll be using that template. I'm going to go fairly quickly because this is just plugging numbers in and solving a formula. This will be my x1, my y1, x2, y2. I'm going to go ahead and label a bunch of these. I'm going to pause and then come back after I get these labeled. So I went ahead and labeled this whole page. And I'm going to move on with finding the slope of this first one. So slope can be found using y2 minus y1 over x2 minus x1. So we just plug our numbers in there, but the important thing to remember is to put your template first with your minus signs in it so that you don't forget those negative signs. y2 minus y1 is negative 15 minus negative 16. x2 is negative 7, x1 is 19. People seem to like to address the double negative by just changing it to a plus, so we will do that. Negative 15 plus 16 is 1, and that is in the denominator negative 26. One thing to understand about slope is we never want to have the negative in the denominator because that slope reads up 1 and to the left 26. We don't want to graph to the left, we want to graph to the right. So it's important for you to know that these two fractions are equivalent. Now this slope reads up 1 and to the right 26. So again, important to understand that the negative should always be placed in the numerator if we do have a negative in the problem. Moving on to the next, slope is y2 minus y1 over x2 minus x1. And we're going to put our template with our minus signs already there. y2 is negative 7, y1 is negative 19, x2 is negative 2, x1 is 1. Again, we'll change the double negatives to be a plus. Negative 7 plus 19 is going to be 12. Negative 2 minus 1 is going to be negative 3. So again, we have the negative in the denominator, which we don't want. We will make that negative 12 over 3. And then we will recognize that negative 12 over 3 can be simplified to be negative 4. But we want to make sure that we are always representing the slope as a fraction. So I'm going to write that as negative 4 over 1. I'll leave that there for a moment so you can pause if you need to. So again, y2 minus y1 over x2 minus x1. Put our fraction bar with the minus signs already in there. y2 is negative 4, y1 is 7, x2 is negative 6, x1 is negative 4. We need to clean up those signs in the denominator, make it a plus sign. Negative 4 minus 7 is going to give negative 11, and negative 6 plus 4 is going to give negative 2. We have a negative over a negative, which is going to divide to make a positive. So again, if we have two negative signs in our slope, we need to rewrite that so that it is positive. It's the same thing as integer division. Negative 11 divided by negative 2 would make a positive 5.5, and so that's really what's going on there, is where if I was to kind of write this idea out a little bit, I'll do this in green. This is the same as negative 1 times 11 over negative 1 times 2. The negative ones are going to divide. Negative 1 divided by negative 1 makes positive 1, leaving positive 11 over 2. That's kind of why that all works. Next, y2 minus y1 over x2 minus x1. Put our template with our minus signs in there. y2 is 16 minus 8, 9 minus 20. 16 minus 8 is 8. 9 minus 20 is negative 11. And so I get 8 over negative 11. Cannot simplify it. The negative is in the denominator, though I don't like that. We're going to move the negative to the numerator. Negative 8 over 11. Okay, next set, y2 minus y1 over x2 minus x1. y2 is 8, y1 is negative 13, x2 is 17 minus 17. This is going to be an interesting one. It's going to be unique. We'll talk about y in just a moment. Those two negatives will make a plus. 8 plus 13 is 21. 17 minus 17 is 0. So this is going to be what we called an undefined slope. And what's happening there is we are dividing by 0, which cannot be done. And so that is, again, going to be undefined. What this would look like on a graph is anything with an undefined slope is going to be a vertical line. The reason that it's a vertical line is that there is no change in x. And so if I think about this as the change in y divided by the change in x, the y is going up and down on that red line, but the x, so I'll just put a symbol, the y is going up and down, but the x is not changing at all, so it's 0. And so when we have 0 in the denominator, that cannot be done, it's impossible, and that's why we call this an undefined slope, because it is a vertical line. Moving on, you're almost never going to see an undefined slope, by the way. It's very uncommon, but it is important to understand that that exists. For our template with our minus signs, y2 is 3, y1 is 3, x2 is 20, x1 is 19. 3 minus 3 is 0, 20 minus 19 is 1. We can divide a 0 by 1, and the answer is 0. So this one is going to be unique, just like number 5. This is going to have no slope. And so if we were to graph this thing, we can see that if we consider, again, the change in y over the change in x, the change in y is 0, and the change in x is 1. And so what that is saying when we graph it is don't go up or down at all, but go to the right one. Now go to the right another one, up and down 0 to the right 1, up and down 0 to the right 1, up and down 0 to the right 1. So when we have no slope, we do have a change in x, but there is no change in y. So number 5 and 6 are unique ones that will almost never appear, but it is important that you see them and understand that's how that works. All right, number 7, y2 minus y1 over x2 minus x1. Put our template first. y2 is negative 15, y1 is 0, x2 is negative 11, x1 is 3. So we have negative 15 over negative 14. Again, we have an instance where you have a negative divided by a negative, which is going to be equal to positive. And again, the reason why that works is we can consider that to be negative 1 times 15 over negative 1 times 14. And the negative 1 divided by negative 1 would make positive 1. So that's going to be the same thing as 15 over 14. Moving on, y2 minus y1 over x2 minus x1. Put our template down. y2 is 10, y1 is negative 2, negative 11 minus 19. We're going to clean those signs up by putting a plus sign there. 10 plus 2 is 12. It's a terrible looking 2. Negative 11 minus 19 is negative 30. There are a couple things we need to address here. That negative needs to move to the top, negative 12 over 30. And we can simplify this. Those are both divisible by 6. That's going to be negative 2 over 5. That's going to be it for this first page. We're moving on to the back. So as I did with the front page, I'm going to go through, this time I'm going to go all the way through putting my templates in while I pause the video, just so you don't have to wait to watch me do that. Alright, and so I have all my templates filled in. I'm just going to sling the numbers and talk through these. And so again, this right here is something that you should be doing for every single problem. If you are not doing that, you're putting yourself in a position to make silly mistakes, not because you lack intelligence, but because you are lacking organization. Organization is a big deal with these. So we've got 15 minus negative 10, negative 15, a minus 6. We'll take care of that double negative. That's going to give us 25 over negative 21. We do not like having that negative in the denominator, so we're going to switch it to be negative 25 over 21. I'm going to go through these fairly quickly, so pause as you need to. Negative 18 minus negative 18. This is going to be plus. Negative 15 minus 12. We would have 0 over negative 27. First of all, I don't like the negative in the denominator, so I will address that. It's kind of weird to have a negative 0, but beats having the negative in the denominator. And if we remember, in terms of change in y over change in x, let's take a look at this. We would have no change to the y, and x would be going forward by 27 each time. So we would be going up and down 0, to the right 27, up and down 0, to the right 27, up and down 0, to the right 27. This would have no, or what did I call it on the other page, a zero slope, a slope of 0? Yes. It is a slope of 0 or a no slope. Would be a flat line on the graph. Number 11, we would have 8 minus negative 20, and then over 5 minus 3. Let's fix those double negatives. And that would give us 28 over 2, which is equivalent to 14 over 1. Yep. Okay. 9 minus 8 over negative 17 minus 15. So 1 over negative 32. We want to fix that. Negative 1 over 32. Our negative values should always be in the numerator of our slope. Number 13, 1 minus 12, and negative 9 minus negative 19. Correct our signs. 1 minus 12 is negative 11. Negative 9 plus 19 is negative 10. Again, we have a negative and a negative. Those are going to make a positive, so that is equivalent to 11 over 10. y2 is 5, minus y1 is 2, negative 7, 12. 5 minus 2 is 3. Negative 7 minus 12 is negative 19. Again, we need to fix that. Negative 3 over 19. Negative 3 minus negative 12. 15 minus 6. So negative 3 plus 12 is going to be positive 9. 15 minus 6 is 9. This is going to be equivalent to a slope of 1 over 1. Negative 17 minus 3. 19 minus 9. Negative 17 minus 3 is negative 20. 19 minus 9 is 10. This is going to be equivalent to negative 2 over 1. That's it for this video. I hope this was helpful, and I hope you have an awesome day.